Let's see. And we are live, coming to you direct from the calculus class. Dun, 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 dun. Via Dave Christian's board. Alright. Okay. So, welcome to class, everyone. Today, we're going to do something with graphing. As you can see, I've got 3 coordinate planes already graphed here. They're very beautiful, I know, I don't have to mention it. Let's start down here, and let's say that I have some f of x equals, you don't have to write this down right now, it's being videotaped, you can all watch the video. I'd rather you just focus. F of x equals 2. Cool, right? Good enough? Yeah. Alright. So it's just 2. So what does that look like?
Like a straight line.
A horizontal line at
2. Y equals 2.
Okay. I think I can manage that. Alright. There you go. Not bad. We'll squiggly bit at the end. It's alright. Now, I'm going to do something a little bit different than we're used to. I want us to figure out something based on this graph. If we take this graph, right, and we say this axis, the y-axis, and the x-axis are boundaries, I want us to find the area underneath this line. Starting at 0, it would just be 0, right? There's nothing there, right? Okay, it's not going to make no sense right now, but it will in a second. So I'll plot this point. This graph here will be the area underneath this line, okay? I'm doing that. You guys get it?
No.
Yeah, the x is in. Well, we're going to do it as we go. So now here, that's why I said it wasn't going to make much sense in the beginning, but it will as soon as I make this next step. Now, at this point 1, I'm going to block that off. And now, I want to figure out what's the area within the boundaries here. So it goes over 1, it goes up 2, right?
Oh, no,
So it's 2. So it's the area under here is 2, right? So at 1, I'll plot this point 2. Cool? Pretty cool with that? Makes no sense, right? Alright, okay, fine. And now, at 2, I'm going to erase this line. I have a new boundary now. And I want to find the area here. 4, right? Okay, so 2, 4. Okay. That's pretty good. Interesting. Looks like a line right now. Oh. Okay. Now I'm gonna do this.
Wild guess. 6.
6 wild guess. You guys, I think we're onto something here. Hold on. I saw this like
6.
Okay. And then last one. I know you guys get it. You're too smart for this.
8.
This is kitty stuff. 8, right? Okay.
And that's the derivative.
Thanks.
You spoiled it.
No, you didn't.
Okay. Cool. All right. Now we're gonna connect this line.
Connect it.
Let's connect.
Connect me.
That's not how it goes. All right. So we're gonna connect these dots, and hey, we get a straight line. And if I were to figure out what the equation of that line would be, what would it be?
2x.
f of x equals 2x. Interesting. Jesse noticed, and I'm sure maybe some of you also noticed, that what's the relationship of 2x and 2?
Oh, that's
2x
the
is the integral.
that's the
yeah.
anti-derivative.
Antiderivative. That's a nice one. Maybe in Latin. F of x, this one, we'll call it not f of x, that's silly. We'll call it g of x.
Couldn't you say that f of x is the derivative of 2x as well?
Yeah.
So then how do you use it? It's going back to yesterday's lesson, how you get the derivative of the original is the integral of the original. That helps with your root.
No, f of x is the antiderivative of g
Don't
of
be
x.
too confused about that. What I was doing yesterday was just like, it was just like a method of just instructing you.
Because I'm saying, how do you look at it? Like, do you look as g of x as the original, and then f of x is the derivative?
There is no original.
So then why are you saying it? Like, you're just going backwards.
It's just like, don't think of it as an original, like there's one original and there's one, it's just like g of x is the integral of f of x. Does that make sense?
Oh, okay, of f of x.
Right?
Yes.
Okay. And f of x would be the derivative
Derivative of that.
Yeah, good. All right, good. Okay. Okay, cool. All right. I'm feeling pretty good about that. That's an interesting observation. There. That the area. Start teaching calculus to kindergartners, so you guys don't all know my secrets. But so interesting. The area under this curve is the integral here. Okay. Let's do this one then. Okay. So if I draw this line, this is going to be 0 again. And what's the area here?
Oh.
Smarty pants. What's the area of the triangle?
Base times height.
1/2.
No, let me do it.
1/2 base times height. The base is 1. The height
So
is
2. So it's 1.
So it's 1.
Yay!
Okay, so I have 1.
I did that.
1. And I helped. You guys ever see those commercials? It's like mom made dinner as a little kid, and he's like, and I helped.
No. It's only you. I don't know what TV show you're
Alright, never
watching.
mind. It's like old. Alright. What about 2? The base is 2, the height is 4. So what's the area?
4.
4. Right? Okay, so 2, 4.
6, 8. Really appreciate it.
Alright, 3. Base is 3, height is 6, right? 3 times 6 is 18, half of that is
9.
9.
9
So I go 3, 5, 6,
Yeah.
7, 8, 9.
Height is over
Okay. And then 4, now let's do 4.
It'd be 16 of them things.
Base is 4, height is 8. 4 times 8 is 32. This would be 16, which is above my graph. Okay, fine.
It's an exponential.
It's a curve.
What's the equation of that?
Is that 2 to the x?
F of x, or h of x we'll call it, equals x squared.
Oh, that's
Right?
Because it's the
1, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, right?
Yes.
Double, what's it called? No, what's it called? Integral. Double integral.
Yes.
No.
That's what it sounded like it was coming out, right? So, what can we say about h of x in terms of g of x? Tom.
You can say h of x.
Mhm.
H of x is the integral of g of x.
Very good. And what can we say about g of x in terms of h of x? G of x is the...
Derivative.
Very good. And f of x is the... Anybody? G of x. So, what did we just find out here?
We found out
We found out. No.
that you can plot the derivative, the antiderivative.
Oh, we can graph it now.
From the area of your equation.
The area under the curve.
Yeah.
this gives a kind of realistic understanding of the integral, right? What was the derivative? What did we say? It's the derivative, but it's also the what of a graph? The slope, right? So if the derivative, bless you, the derivative is the slope of a graph, and the integral is the what?
Area.
Under the
Curve.
So the integral is equivalent to the area bounded, you guys should write this down, by the function and the x-axis. Now, this is a very loose definition. If I would really be in front of a group of PhD mathematicians, they would probably be screaming at me right now. Because this is really kind of loose, all right? Because the truth is that I'm taking this and I'm only saying from this boundary as well, right? Like, for instance, this, I didn't say, oh, the area all the way from the left, right? Like, I could have gone on infinitely, right, to the left. So you could say the area bounded by the function in the x-axis, okay? And this works loosely. Do you guys kind of get that? So the derivative is the what of a graph?
The slope.
The slope, and the integral is the it's area under the function, right? Area under the curve, area under the line, area under the whatever. If we kept going, it'd be pretty difficult to find the area under this.
Yeah.
But that's kind of cool if we think about it, because we don't necessarily know what the area under this little bit is. That'd be pretty tough to figure that out, right? Because it's a curve, right? I don't have any equations for that. But what would the integral be of this? Can we figure that out?
1/3 x to the third cube.
Right? The integral of h of x dx would equal 1/3 x cubed. Does everyone know where she got that from?
738.
Right?
Plus
It'd be
C.
plus C. It'd be plus C. You're right.
Someone's been.
That's why this is a very loose definition, because it'd be like plus.
Someone started their
some
homework.
constant, right? Okay. So if I wanted to find the area from here to here, that would be this function evaluated at what?
1.
1. So I would just plug in 1/3 times 1/3 is just 1/3. So hey, the area under there is 1/3. It's pretty cool. It's pretty nice to be able to know that, right?
Yeah.
You never know when you're going to be on Mars, colonizing the planet
Wow, sometimes I feel like my brain is on Mars.
with vegetables like that one guy did. Yes. Okay. So is that pretty well understood now? Is that pretty well understood?
Unfortunately.
Unfortunately. We just learned something.
Someone's in the bathroom.
I like being in the dark.
In the dark. You can only be in the dark for so long. That's weird. Eventually the truth comes to light. So
Say
the point of going over this is, and this isn't even really presented to you until I think the next section, really, or maybe even one after that. What was that? It's due Monday. It's on Redline. At least it should be. I put it up there on Monday. So the whole idea here is, class, is that we're getting a deeper understanding of what integrals are. Right? First we said it was a what? What do we call it first?
An antiderivative.
Antiderivative. Because it's kind of like the opposite of
A derivative.
very good. So we figured out it's an antiderivative. I am recording, aren't I? I think so. Yes, you are. I have to just do the whole lesson all over again. It's okay. And you guys won't even know. No, you don't have to pretend you don't know the answers. No, I'm just kidding.
I feel like I did.
But it's very good. I mean, it's honestly, I'm very happy that you're so observant with this kind of stuff, because this is the kind of abstract thinking that I'm talking about. Like, really looking at this stuff and saying, oh, look, it's the area of the curve, that's the integral. Okay, cool. So we're getting a little bit of a better understanding of what an integral is. Okay? Now, from here, there are lots of places we can go. All right? But let's keep it really straightforward for now. Let's do a little practice, shall we? Okay. So, first thing. I'm going to erase these beautiful pictures. It's okay. Not one video. So, I'm going to do one for us, and then we'll go through some together individually. So if I say f of x equals 3x to the 4th. Now, there are quite a few ways that we can do this, really only two. But what's that? Do you guys remember that? If I want to find the integral of f of x, if I have the integral of x to the n dx, what does that equal?
X to the n plus 1 over n plus 1.
Over n plus 1. Very good. Okay? Eventually the idea here is to kind of forget about this and just kind of think about it in your head. Oh, I add 1 to this and then I divide by that number. Does that make sense?
Yeah.
Alright, just add 1 to that and then divide by whatever that number is. Now, if I want to take the integral of this, right, I want to find the integral of f of x with respect to x, f of x dx, well that equals the integral of 3x to the 4th. Now, when I say that there are two ways to do this, they're really basically the same exact way, but it's just two different ways of looking at it. Firstly, I can just go ahead and do this whole process, right? Add 1 to that. And what does this become? What's the integral here? What does this become?
3/5 x to the 5th.
3/5 x to the 5th, right? Right? Becomes 3/5 x to the 5th plus c. Right? Pretty straightforward to just look at it like that, right?
Mm-hmm.
Generally speaking, how I feel comfortable with it, you may be different, but what I do is I take the constant out. Because you can do that, remember? You guys remember that? So we can take the constant out of the integral, right? Because the constant's not changing.
Wait, dx is a thing now when you're doing integral?
Say this again?
Dx is a thing now when you're doing integral?
Yes. Yes. Because remember we did this whole thing where it was like dy dx equals some function, right? Let's say x, multiply both sides by dx, and I get dy equals x dx, and I take the integral of both sides. So you have to have that dx in there. You have to have that dx in there, for sure. And this is the kind of thing on the AP test, like they need to see that. Like you need to actually put that on there to receive full credit. So, and it's the proper way of doing it. Does that answer your question?
But you take it off when you actually get the integral.
Right. Right. Exactly. It's kind of like you're just saying, I'm taking this integral with respect to x. Does that make sense?
Yeah.
And then once you take the integral, it's like, it's not there anymore because you just have a function. Questions? All right, so I take the constant out, and this just becomes what? 3 times 1/5 x to the 5th plus c, which is the same thing as 3/5 x to the 5th plus c. Right? Now, this may seem like an arbitrary, like extra step, extra work. Why am I taking the constant out when I'm just going to put it back in? Right? But the thing is that sometimes this is going to be beneficial for you. And in the long run, there are other methods there are going to be more difficult integrals we're going to do, where it's going to really be beneficial to take the constant out, because then you don't have to think about it at the same time as everything else. You know, it's kind of like breaking up your work, right? Rather than thinking, okay, it's 3 and then 5, and it's just like pull the 3 out, take the derivative of whatever's in there, right? And then just pull the constant back in. Does that make sense? Okay. So that's just how I do it. You don't have to do it that way. But does everyone remember the rule of being able to pull the constant out?
Yes.
Right. So we basically have only learned 2 rules so far. We've learned this rule, which is kind of like the reverse power rule in a sense, and we've also learned the fact that you can pull a constant out. Okay? Everything else is kind of just knowing different derivatives of different integrals. Okay, next rule. You guys get this? What about if I have f of x equals 2x squared plus 3? And I want to find the derivative of f of x dx.
Derivative?
I mean the integral. Thank you.
So 3x to the third.
This is how I would recommend you writing this. I recommend you putting it in parentheses.
What about the? Okay. Oh, wait.
I'm just rewriting. I'm writing the integral in that step. Yes, ma'am.
What if we just pull the side of the integral of f of x times c of x over the equal sign? Yeah, what if we just have that equals the x? Do we have to rewrite it like that way?
You should. I mean,
So then
yes.
Skip that part.
Yes. You've got to write this. You've got to write
Can we
this.
start off with that?
Yeah. You don't have to write this. You don't have to write this. If I just say find the integral of f of x, you don't have to write this. But you do for sure have to write this. Okay. Just because for right now it's like, oh, okay, it's straightforward. I just take the integral, but later it might not be. It's not going to be so straightforward. So it's good to get in the habit early on of just writing out the integral. Okay. But the reason why I say to put it in parentheses is because if I don't, right, and I just have 2x squared plus 3, and then I have a dx here, it almost kind of looks like it's just the integral of 2x squared and then plus 3 dx. Like it doesn't even look like they're kind of connected, right? That can kind of be a little bit confusing, especially if you're doing a really long integral, right? And sometimes you're going to be doing 2 integrals in one, and it just gets kind of a mess. So I recommend putting it in parentheses, okay, when you have multiple terms in one integral, okay? But right now, yeah, it seems like, oh, okay, I can just do this one and this one, but we don't actually know that we can do them separately, right? We don't know that, but we can. So this is another rule. If I have if f of x equals g of x plus h of x, then the integral of f of x dx equals the integral of g of x plus h of x dx, which equals the integral of g of x dx plus the integral of h of x dx. What does this tell us, Javon?
It's saying that. Whoa.
It's just like natural law.
It's like it's just like reversing, meaning like. I don't know how to explain it, but like I understand like what it is.
You understand?
Yeah, it's like what we did yesterday when we were finding the like antiderivative of the derivative, which was just like the original equation.
Can anyone explain what this line specifically shows in words? What does that show?
If he wants to see
Yeah.
the integral of g of x plus h of x with respect to x is the same thing as the integral of g of x with respect to x is the integral of h of x with respect to x.
So it doesn't matter when you take the integral.
Oh.
So what can I do when I have two terms, right? Like with an addition, or
Either do them separately and then add them back together, or do them together.
I can do them separately. That's what I was kind of like looking for. That was technically accurate as well. I can separate them, okay? This is also true for subtraction. Plus or minus, okay? That's true for subtraction. What do you guys think? You think it's true for division, multiplication? Not true for multiplication and division. Because if I had, for instance, 2x squared times 5x, right? I don't separate them, that's kind of just one function, right? But I can't just separate them if it's multiplication and division. I can only separate them if it's addition and subtraction. Okay? So this integral then becomes what? The integral of 2x squared dx plus the integral of 3 dx. Right? Okay? Once again, you could take this constant out. Sometimes I do, sometimes I don't. It's okay. What would this one be? 2x squared. What would the integral of that one be? 2/3 x to the third. 2/3 x to the third. All right. Plus c, right? Okay. Plus, what would the integral of this one be?
3x.
3x plus, I guess, c again. I guess this should be c1, this should be c2.
Wait, do we need to do C1 and C2?
Good question. What do you think?
What if we do it together?
Yeah, what if they're constants? Why don't we just add them?
So you just do plus.
Very good. Since they're both arbitrary constants, I don't need to have two arbitrary constants being added. Does that make sense? I can just combine them, right? 2/3 x cubed plus 3x plus c. I honestly, in practice, I would not have done this. I just wanted to do it so this point would come up. But in practice, I would have just written up 2/3 x cubed plus 3x and then added the c at the end. Right? That's generally the last step, is remembering to add the constant. But you have to do that. Because technically, it wouldn't be correct if you just said this. Because the integral is more general. Alright? You have to add the constant. Alright? Cool. Good. So now we've got three rules. We've got our kind of reverse power rule, we've got our constant multiple rule, and we've got our addition and subtraction rule. Right?
Mm-hmm.
Alright, cool. Alright. Now, I mean, you guys were really, this is really good. I'm very happy right now. For a lot of reasons. Mostly because you're getting this so well. Now, the thing is from here we can go in a lot of directions. And I'll be honest with you. Integrals become very, very challenging at a certain point. Okay? They do. Right? But there's no reason to be afraid of the integrals. There's no reason to be like scared that, you know, you're not going to be able to get it. Okay? Because the truth is that this is all there really is. Right? There's a lot of different rules, there's a lot of different things, but the fundamental concept here you guys got. And starting from there, it's like a foundation of a building. Once you got a strong foundation, that's it. That's all we gotta do. Okay? So, how much more time do we have?
We got like 15
Have
minutes.
about
10.
Oh no, 10 minutes because chapel day.
Okay.
Jesse, are there good songs today?
I'm messing that college band.
Okay, thanks.
But they're good. I think they look good.
Wait, that Crossfire guy's not coming back, right?
This month.
No, he's not. Don't tell me I'm not going on stage again.
Women's basketball for like
That's right.
I'm not doing that again. What?
Like, champions?
Yeah, I'm putting Liam up there. Okay, you can go ahead now. No, actually, let's talk more. I don't want to Put Mike right there, boy.
What's the integral of sine of x?
Negative cosine.
Negative cosine. Everyone understand why? Why, Katrina?
Sorry.
What's the integral of sine of x?
Cosine.
Cos.
This is the derivative of cosine, isn't it? Right.
So it would be not the positive cosine, it would be
Negative
the.
cosine.
Very good. Very good. All right. And the integral of cosine of x?
Positive sign.
Wait, negative cosine.
Positive sign.
Wait, sine equals negative cosine.
Sine of cosine.
Can't worry
The
about
derivative of sine of x is
Negative cosine.
positive cosine.
So which one's negative? Cosine. The derivative of cosine is negative sine.
Yes. Class, everyone please pay attention. What's the derivative of cosine of x?
Negative sine of x.
Negative sine of x. And what's, if I have f of x equals sine of x, what's the derivative of sine of x?
Cosine
Cosine.
of x.
Very good. What's the derivative of tangent x?
Secant squared.
Good, so what's the integral of secant squared of x?
Tangent.
Very good. Plus c.
Yeah.
Yeah. Okay.
That's all.
What's the derivative of ln of x?
1 over x.
So what's the integral of 1 over x? Let's see, what's the derivative of e to the x?
E to the x.
So what's the integral of e to the x?
E to the x.
Very good.
Wait, I don't know how to do the
That's dumb,
like
favorite.
the e to the something x. I forgot.
Oh, like e to the 2x?
Yeah.
Well, it's e to the 2.
Very good. Let's do that. Very good.
It's 2 times e to the 2.
I know, I just totally forgot like the exponential rule.
If I have f of x equals e to the u, where u is a function of x. What do I mean if a u is a function of x?
That means u is like x.
It's got some x in it or something,
x
right?
plus something maybe.
It's dependent upon x, right? It's some function of x, whatever it may be. Then f prime of x equals e to the u times du dx. Okay? Simple as that. So it's the derivative of whatever's up there. So let's put this in real example. If I have f of x equals e to the x squared, then f prime of x equals e to the x squared times what?
2x.
Okay.
I was gonna go over to
12.
I was gonna do e to the x and then I was gonna times 2 e to the x. Like when you don't bring down that 2.
No, because it's not e. If it was e to the 2x, then it would be like e to the x squared, right?
I know. Okay, like the second part when you actually like copy it over. Okay, never mind.
No.
Oh, you're
Like,
thinking.
You know, I'm thinking. There's one I believe. I think I don't know. Where like you do like e to the x squared, and then when you do the derivative, you copy it as e to the x. So e to the x squared times, and then when you do like the actual like derivative, like I thought you brought down that to the exponent, so it'd be 2 e to the x negative or negative 1. Like there's isn't there something like that where you actually, or is it when it's e to the 2x that you bring it to? Okay.
Well, you're thinking e to the x in parentheses, then square the entire thing. Then that's when you do that.
If I had f of x equals e to the 2x, right? Then if I took the derivative of this, f prime of x equals e to the 2x times the derivative of 2x is what? 2. So it would be bringing the 2 down, right? But why is that? Is because I could also write this as f of x equals e to the x squared,
Yeah, I think that's what you do.
right? Something like that? Anna? No, I
No.
do wrong. Okay, and then if I use the chain rule on this, right? First I got to use the power rule. I bring this down, right?
2.
So it becomes 2 e to the x times
E
to the 2 minus 1, right? But then because it's inside of parentheses, what do I have to do?
E to the x, the derivative of
The
x.
derivative of the inside. You remember that?
Mm-hmm.
You guys remember that?
That's where I was saying.
Right? And this would be e to the x, right? This is a very complicated way of doing this problem. But I then have 2 times e to the x squared, right? You see that? 2 times e to the x squared, right? But whenever I have an exponent to an exponent, right?
You're gonna multiply.
I just multiply them, right? So it ends up as the same thing. Does that make sense? Okay. So that's just showing that the power rule, the chain rule, it works here. It's not arbitrary, this whole thing here. Okay? But interesting. That was a good question. I'm glad you asked it because look, if I said the derivative of f of x, where f of x is e to the x squared, is e to the x squared times 2x. Now, what if I asked you, what's the integral of 2x times e to the x squared dx? What would that be?
Okay, so you separate them.
Can't separate them.
Well,
You're both
wait,
fine.
you're asking for the integral of that?
You can pull out that too.
Think.
Take out a constant.
Take out.
Oh no,
Derivative
you do
of
2x
this-
times e to the x squared. The 2 different intervals.
No, you can't.
Why not?
Because it's, remember what I said, if it's multiplying or dividing, you can't separate them. What was that? Can't do power rule.
Well then,
But what you
no.
can do is look right here.
But what
And
if
then
we didn't
think.
have that?
If you don't have that, then you just, there's a way.
You're done.
There's a way.
So
There's
you
a way of
can't-
understanding.
You can't find the integral of
There's a
x.
way of understanding, but we're not going to necessarily go into it
Oh,
right now, but I
so
want you to
it's-
see this.
Why wouldn't it be?
So the integral of that would just be e to the x to the square.
Oh. So what you have to do is get every
So all you did was
single number
combine those
possible
two.
with e's and x's
Well, why
and
wouldn't
take
it
the
be-
Oh, y'all was right. Did you see that, Chris? No. Okay.
What was that? Tell me.
The integral of 2x e to the x squared like times the x. Why wouldn't it be 2/3 x e to the x cubed? So you can get the other way.
Because that rule that we had is only for x to the n,
See how I'm not paying attention?
not for e to the x to the n.
Okay.
Does that make sense?
So
You see that I got that one right. I should get like extra
How
points
would
on
you?
mine.
How is it e to
1,000.
the x squared? Let me go.
Yeah.
Hello, sir.
Because heard these kids weren't really behaving, so I thought I'd check.
Oh goodness, I have trouble with them all the time. They just want to do calculus all the time. I have to stop them.
Oh no, it's a disease.
Thanks.
Me too, right?
All right. Look, guys, I'm making this seem way harder than it is because I'm doing that on purpose. Look, the derivative of e to the x squared is what?
E to the x squared times.
I could just rewrite this, can't I? 2x e to the x squared.
See, that's what I saw. I was,
Right?
I was undulating
Oh, I
on
didn't
that.
see that.
bug.
I didn't see f of
Big.
x. I only saw f prime of x. Like yeah.
F of x is e to the x squared. F prime of x is
You're like,
this,
what?
right?
I think we
When
did
do you ever
yesterday.
like any drawing?
I actually like these. I actually
But
get these.
listen. The thing is this. What I'm doing for you right now is just showing you.
no, it's an English.
I got those things
Our
last
English
time.
teacher doesn't like what you
I got
you
to
say
save my
things or
soul.
what was the other one? I was just waiting for it.
This is how we do
And we
it.
were talking about it yesterday. I was like, whenever anyone says thing or like whatever, I always like correct them.
Because it's
This
not
is how we
specific
do
enough.
It
work.
says that it
It's
says
a word in English language. I should be able to use
My
it.
last essay, I put thing, and I got instead of 100, I got 90. That's the only thing I had wrong.
Yeah, you can't say thing. See, I
Because
think
the
it's
thing
a
has a specific object you can refer to.
But continue.
The thing is,
I said, put
The
your
issue
eyes
is the
on my.
explain
You
it.
just
It
close
seems
them.
like a very mathematical way
Okay,
of
freak
English.
mine.
I like it. All right, so look, it's. I know it looks confusing here because I'm showing it to you in this way, but the point is, if the derivative of this function is this,
Okay.
then the integral of this is
That.
that.
But if we don't have that, then we have to try an infinite amount of math problems until we find it.
That's not bad. That's. It's just the wording that gets.
Understood.
I see that, but it's the wording.
Yeah. It's the more that we get comfortable with this, the more you get. Look, the idea is you do enough problems like this that you see that and you're like, that's e to the x squared. That's
what I
where the
saw.
abstract thinking comes in.
That's what I saw. That's what I saw.
Because there aren't necessarily. It's not about memorizing the rules. That's why this gets deep.
That's
We're
why
going
I don't know.
deep in the waters of
That's why I
calculus.
listen to your rules and I just create my own path.
Amen. All right. So. So.
Exactly.
Okay.
Create my own path.
Look, the point that I'm making is fairly straightforward. It's just that when you do enough of these type of questions, you get better at it. You know, and
I'm so
trust me,
happy I got
there are
that.
integrals that you could write
Huh?
that I wouldn't be able to do right. I admit my flaw. There are plenty of integrals that you could write. If you wrote this integral for me right now, secant x times e to the x times x squared over ln of x. I couldn't just do that. I couldn't do that right now.
No.
I don't know how many problems I've done, but I couldn't do that.
I don't
for you.
think we should do
I mean, I might be able to if I thought about it for a long time, but I can't. Okay, so understand that I'm not just preaching to you about just being able to do all this stuff, not knowing that some of this stuff is very challenging. And it all looks very challenging in the beginning, but the idea is we slowly get more and more comfortable. So that's why we're easing into it. Okay?
So then,
Oh
what would
my
be the
God.
integral of e to the x squared? What would we have to do to find that? We put it.
I'll do
Okay.
Right? So there are specific things that, like, and honestly, your calculators, they can't do it all the time. They can do definite integrals, but they can't do indefinite integrals.
What's definite?
I'm going to teach you guys about that.
Oh
I read
my.
about that yesterday.
There are
But that's a
definite
lesson
and
for a different
indefinite
day.
integrals. Yeah. But since class is about to be over, the point is
No,
this.
what I read it was that
Mm.
If this is the derivative of that, then this is the integral, right?
It is.
Very good. And okay, class, the derivative is the what of a graph?
Slope.
And the integral is the what of a graph?
The
Area
area bounded
of the
between
function.
the function and the x-axis.
Very good. All right.
Alright.
Good job. All right, tomorrow we'll do some practice problems.
Jesse.
I don't have any strength.
And we'll just keep going.
My strength
All right, everyone say goodbye to...
Like, that's my strength.
Bye, Internet.